Thanks so much for having us. We wanted to introduce ourselves first. So I'm Madison. I work at Baseten. I just moved to San Francisco 5-6 months ago. More about me. I think I'm the last person in the world using Vim still as my text editor, and especially definitely the only woman possibly using it as well.
Hey everyone, I'm Kaushik. I'm one of the fully deployed engineers at Base 10 who kind of specializes on the TTS and voice model stuff. So super excited to be here and give this talk about taking your voice models to the next level.
Awesome. Okay, so we're talking about voice model performance optimizations. And before we do that, we want to dive into two important metric categories for measuring the performance of these voice models. And the first one would be latency, so the speed of conversation, essentially. So obviously in voice AI, latency isn't just like this one number, and it can be the difference between a really natural sounding conversation with voice models and an awkward one. So these are just a couple of the things that we need to measure. Time to first token. So how quickly does your system start processing after the user stops speaking? We also have end-to-end response time. So this measures really the complete journey from the moment a user submits input to when they see a response back. And then we also have token generation speed. So for LLMs, basically measuring tokens per second. This measures how quickly your language model produces subsequent tokens after the first one. And then we also have like a second really important metric category for measuring the performance of voice models, which is throughput. So throughput is telling you how many concurrent conversations your system can handle. And there's a couple of key measurements we really want to focus on here. So one of them is concurrent sessions per GPU. This measures how many simultaneous voice conversations a single GPU can handle effectively. We also have requests per second. This can measure how many individual API calls or processing requests your system handles per second. And then we also have queue depth and wait times. So this is measuring how many requests are waiting to be processed, while wait times measure how long they wait. And throughout all of this, when it comes to optimizing voice models, we have to keep in mind throughput and latency are in constant tension. These are some trade-offs you have to keep in mind, where increasing batch size improves throughput but can hurt individual request latency. So these two things are really in tension, and you really have to be intentional about the conflict between them. And I guess, Kaushik, do you want to take it away?
Yeah, of course. Yeah, thank you, Madison. I think that was a great overview of kind of the two main categories of metrics we use. Both the base 10 as well as just like industry wide to measure the performance. Now I'll kind of dive into the specific optimizations you can do, which really help in scaling up your models and kind of productionizing them to fit your traffic use cases. I think just like one of the most common and one of the easiest, honestly, is connection pooling. It's something we've seen a lot, especially as an FDE, is that through connection pooling, it can like take your latency from above 500 milliseconds for the TTS model down to sub 300, sub 250. Essentially, connection pooling is that instead of having to send multiple requests, as you might with like Python's request library, you use async IO or AI HTTP, and you open up a session. The logic behind this is that opening and closing connections is expensive as your traffic scales up. This is the handshake as well as the cleaning up. It really adds up, especially as you scale up and handle more and more traffic. So connection pooling removes this overhead associated with these operations and makes it a lot easier to kind of handle concurrency and handle a lot of requests at once. Kind of moving on to kind of the more model-specific stuff, we highly recommend you use an engine for this. So TensorRT LLM is our engine of choice. It's from NVIDIA. You can think of it as a framework that lets you optimize transformer-based models, we'll be talking about Whisper from OpenAI, as well as Orpheus from Canopy Labs. These are both transformer-based models, luckily. So this means you can make the most of them using TRT LLM. So it gives you stuff like in-flight batching, quantization, speculative decoding, and a bunch more things to really get the most of your models. Moving on to the infra-heavy stuff now, and once again, this applies for any models you might have in your agentic pipeline. KV cache overloading. So KV cache enables for efficient inference. It's a massive driver in reducing the latency and the TTFB for language models. And now we bring it over to TTS and STT models. So KV cache overloading, as the name suggests, it allows the requester with the caches to really minimize the latency as you scale up and add more and more replicas. That even though you might have a bunch of different pods which have these, you'll always get the lowest latency with this cache overloading. And finally, wake caching. So cold starts are often overlooked. This is a time taken to go from no replicas, your model sleeping, to waking it up, getting to the first replica. So by bundling the weights into the container itself, instead of having to download them separately from Hugging Face, you can cache these weights, and it can really save a bunch of time when you prevent this download from happening separately. And it's just a great way to make sure that the experience when you get started is as good as whenever your models are already running. Kind of moving on to the specific optimizations now, I'll talk a bit about Whisper, which is OpenAI's speech-to-text model. And kind of the specific things Baseten has done to optimize these. If you could go to the next slide, Madison. Yeah, thank you. So one thing we kind of did, we implemented a WebSockets version. You can think of WebSockets as a separate as an alternative to using less API with connection pooling. So WebSockets, the biggest advantage is that you get partial transcriptions. So kind of if you're talking and you want live captions as it goes along, WebSockets is a fantastic way to achieve this while maintaining the low latency. We've seen sub 50 milliseconds for each audio chunk which is generated. Something we did was move from a Python TOT LLM to a C++ TOT LLM framework. So this enables actual multi-threading capabilities. Unfortunately, because of the global interpreter lock, the GIL with Python, you can actually achieve true multi-threading. So by shifting to C++ back framework, we notice about an 18% increase in just speed. And then finally, what we do with Whisper is dynamic batching. So instead of having to wait for a bunch of requests to come into a batch and send it out, we do this in flight. We continuously send out requests, and we can batch them as the kind of in flight to really minimize any latency and improve the time to first byte for Whisper. And then kind of Orpheus, which is a fairly new TTS model, which has kind of changed the game. It's a fantastic model. One thing we do is that we Twitch compile all models. I recommend this even outside the domain of just like voice agents, any language models. Please Twitch compile them. This optimizes the model for the specific hardware you're using, for the kernel you're using on the GPU. So Orpheus has two models. It has a Llama model and a Snack codec model. We Twitch compile both of these to get the best performance for them on the hardware we're running them on. We quantize Orpheus as well as its KV cache to FP8. This really saves a lot of memory on the GPU if you can quantize it, and this allows for more concurrency actually because you have more memory to run more requests in parallel. So if you want to improve throughput, you want to improve concurrency while kind of reducing any potential queue times, quantization is a very easy way to achieve those goals. And then finally, this is kind of like a fun little quick. Orpheus, the base model, if you guys do use it, there's about 600 milliseconds of silence at the beginning. This is just a byproduct of how the model was trained. You can just cut this out and you reduce the time to first audio byte, which is not initially equal to the time to first byte. And just by doing this, you can get better end-to-end latency and you just get a smoother experience. So once again, those are kind of the two main models we've seen being used, really popular, really performant. And these are just the ways we recommend you get the most out of them. Yeah, and I think that wraps up the talk. We kind of discussed the metrics, which Madison did a fantastic job going over, and these are the easiest ways to actually measure your performance, like an apples to apples comparison for your models on one provider with another, and then the optimizations we do and what we recommend you all to do if you plan to kind of scale up voice models to make sure that you can productionize them effectively, that they can handle the traffic which you are seeing at a production level, and B, just make sure that you can make the most out of these models. And there's some really easy things you can do just to improve the performance as we've discussed. So yeah, once again, thank you so much.
Thank you.
Kaushik and Madison, thank you very much. Can I ask you to flip to a couple of slides back? Just in case anybody wants to take a screenshot. I think not this one, maybe one before.
Probably this one.
Yes,
I think
yes.
that's the one that Kaushik made getting the most. Yeah.
That is a power slide right there. Okay, how difficult is it to build these systems, like connection pooling, the KV cache aware routing? Like, should I have in mind? Yeah, and are there good solutions out there that can get people started?
I think like a good philosophy is kind of just like Occam's laseling a lot of things. It's like the simplest solution, just like simple fixes can go a long way. Connection pooling is just something we've seen a lot of people overlook. They're sending one request at a time. It's like, man, why is my latency so high? Why is my TTFB so high? It's because you're not sending these concurrent requests at once. They're waiting one after the other. Connection pooling just makes less APIs a lot faster, because you kind of mitigate the overheads of making multiple handshakes and establishing multiple connections. And it's like, hey, I've already made 10, 20 connections. The handshake is established. I don't have to set it up again. Let me just keep reusing these connections I've established. And we've noticed that in production, this can lead to like immense speed ups. Connection pooling with less APIs or using WebSockets. These are the two kind of like client-side improvements you can make to really get benefits. KV cache overloading, of course, this gets into the infrastructure. This is not an easy thing to set up. This isn't something like I think, especially if you aren't using like a provider like Baseten or Fireworks or Together, which, gives you these capabilities with the engineers. If you're using AWS or Azure, it's a lot tougher. You don't have the control you would want to have this. But at least on Baseten's and we've set up KV cache overloading, so that whenever you make a request, if it kind of contains the same prefixes as previous requests, we send you to the pod that processed it so that it has a KV cache hit. Because once again, even with KV cache overloading, one thing we do is that when we spin up a new replica, we copy over the cache to kind of improve hit rate. But this pre-filling of the cache does take some time. So just with KV cache overloading, even when you do scale up to handle more traffic, you never have a latency hit.
Yeah. Can you go on to the next couple of slides?
Yeah, of course.
Yeah, I imagine a lot of people might be starting with just like Whisper. They might do this on like a demo, kind of just like on a single machine. But then at some point, we've already covered kind of like what is the gradual journey of just going from like some of like the out of the box voice APIs to now starting to do this yourself. And then you're hitting all of these scaling challenges. And I believe that some people might already be there. They might just be like going through the struggles of how to handle like that scale. And are there good resources to figure out? Do you just learn this by trying everything, or at what point is there like almost like a more consolidated way of like learning how to scale these things?
I think that's kind of a big. I think once again that's kind of the benefit of going to like an instance provider. Like once again, these 10 Fireworks Together, I think a common model as well. It's that we can handle these scaling challenges on your behalf. I think otherwise, like you're setting up an AWS, like you need the load balancer, you need the EC2, you need the SageMaker, and the Bedrock and whatnot. I think it becomes a lot tougher to kind of manage costs effectively. I think like there's often times where a really easy solution is like, hey, just like get a bigger GPU, or like, hey, just get like 10 replicas. But obviously, cost is a really real factor and a really limiting factor, especially for startups and people just like starting out in the space, ramping up, hobbyists, whatnot, right? So I think even with him, like with regards to that, I think there's like good scaling principles which generalize really well. Because what we do on the engineering team at Baseten is different from how AWS or Azure or GCP kind of handle it. So I think just like the best policy is to just like research the components you need and kind of what goes into each of those. So whether it's a load balancer and how to like effectively delegate. And I think like it's the infrastructure side is one aspect of optimization. You have the model side, which is probably the easiest to get into because you can use VLLM or SGLang or TOTLLM, and you can get model side optimizations which can make a big difference. I think it's a lot harder to manage infrastructure and networking side optimizations just because it requires a lot more kind of niche and domain specific knowledge, which it's a lot more difficult to acquire when it's not a product you have control over necessarily.
Awesome. What is a good way to keep in touch with you guys? follow your work, to connect with you if folks have more questions. Actually, there is already one more question. But first, how do we stay in touch?
I think, yeah, go ahead, Madison.
Yeah, I'm mostly on Twitter at Madison Kanna. But we also have Baseten.co, and we have an amazing blog on Baseten where we talk about a lot of issues like this. But go ahead, Kaushik.
Yeah, I can, I'd be happy to drop my email or LinkedIn in the comments if that's the best way.
Awesome. But also knowing about the blog, that's excellent. Ravi, before we let everybody go, Ravi's asking, any consideration for multilingual voice?
Ooh, for multilingual voice. I'm assuming this is on the TTS side. I think Cocoa is probably the best model for that. I think fundamentally, optimization wise, there's no difference because this happens at a model level. So as long as it's I actually don't remember the architecture for Cocoa off the top of my head. But kind of just if it is a Llama architecture, if it's a language model based architecture, you can use TLLM, you can use VLLM, you can get these optimizations done regardless. Ultimately, multilingual is just a product of how the model is trained itself. So any model level optimizations I've discussed can translate over to that, assuming once again the architecture is something which is analogous to transformer-based model.
Thank you very much, Madison, Kaushik. Thanks for coming.